Okay. Hi, everyone. A very massive and big welcome to GDG Polokwane's Women Techmaker event. So I am your host for tonight. My name is Voyo. I hail from Funnabell Park, and I am looking forward to spending the rest of the afternoon, well, what's left of the afternoon with you guys. So I'm just going to quickly share a slide with you guys about what's going to happen, what the agenda is, who's going to be speaking. So in the meantime, make sure you've got your water, snacks, notebooks ready. Okay. So I'm just going to quickly share my slide. Okay. Let's come here. Sorry for the delay. Okay. So as I said before, welcome to GDG Polokwane's very first Women Techmaker event. What we have for today is we've got introductions. So I'll be introducing Carrie, and she's going to be telling us why Kubernetes. Then she's going to give us an awesome demo. And then we've got a little survey after the event that you guys should please fill up. And then we're going to have prizes up for grabs. Well, I shouldn't say prizes, like a few prizes of the same type. So we've got some awesome JetBrains vouchers. And then we've got the closing. So, a little young introduction to Carrie Liebenberg, our wonderful cloud native engineer from Container Solutions. She is a South African, but she works in the Netherlands, and I thought she's just an amazing Kubernetes woman, and thought it would be a great opportunity for us to actually learn a bit more about what containers are, what Kubernetes is, what Docker is, and so forth, right? And we're going to have an awesome demo by her. She's going to talk about from GitHub, Docker Compose, Prometheus, and more. And then I'll be giving out a shout out to our wonderful sponsors for today's event. And then we'll have our survey and the prizes. And I'll be thanking everyone. So I am going to just add quickly, sorry about that. I'm going to stop sharing my screen. I am going to add my lovely, there we go. Just unmute. Yeah.
Hello.
Hi, Carrie. How are you?
Good, thank you. And you?
Are you ready with my jokes? I'm just waiting with the jokes. Okay.
I got no jokes.
You have no jokes? I might have a good knock joke. Are you ready?
I'm ready.
I hope my son is tuning in because he's on his tablet, hopefully watching me. Okay, knock.
Who's there?
Banana.
Banana.
Knock.
What? Who said? Sorry.
Banana.
Banana who?
Knock.
But so just keep going. Am I missing the joke?
No, you're not.
Okay.
Orange. It finally changes.
Orange.
It's orange. Orange, you glad I didn't say banana?
Yes, very much.
So that is courtesy of my son Noah. So he's like the person with the knock jokes. But yes, Carrie, I'm super excited to have you giving us a wonderful talk on Kubernetes, and I look forward to learning from you. Do you want to maybe take it away?
Yeah, sure. I'll take over. Okay. Thank you so much. Thanks for inviting me, and yeah, thanks for giving me the opportunity to spread the word of Kubernetes. Just give me a moment as I find my screen. Cool. Okay. I'm just going to go ahead and jump into the presentation. Cool. So welcome to my talk, Why Kubernetes? My name is Carrie Liebenberg. I work in Amsterdam. I'm currently working in South Africa remotely, though, due to interesting circumstances. And so what do? At work, I'm a cloud native engineer. What I help with is I guide our clients with the cloud native transformation. And one of the things I also try to focus on is culture transformation and preventing burnout across teams. And you might be asking, what is cloud native transformation? So in my own words, it's the journey towards the cloud, going from that perceived slow-moving software approach to a more rapid, faster-moving cloud approach, and we aim for a stable cloud approach. When I'm not at work, so I used to play roller derby before COVID. It's been about a year since I played roller derby, so I like to think I still play roller derby. I also used to go to skate parks with my skates, but as well, not since COVID. So interesting times. And then when I have some free time, I like to play PlayStation. So this is not that often. It took me about a year to finish Horizon Zero Dawn. And it's a really great game. I've left it up there. It's beautiful. Cool. Let's begin. So the structure of this talk, I've kind of got like two halves. The first half, I'm just going to be generally talking about why Kubernetes and a little bit about like what it solves, how it works. And then near the end, I'm going to switch over to an engineer-focused perspective where I actually show you how you can get started with Kubernetes and how you can get started with learning Kubernetes. So just an interesting question to reflect. Where are you now? Where are you in your company, like your whole company? Is your company on-prem? Are you already moving over to cloud native? Or are you learning? Are you just kind of in this phase of learning about cloud native and just still hearing about cloud native, and you could be interested in Kubernetes and what it can offer? So I hope this talk caters for all of these scenarios. Let me know. You can always shoot me a question on Twitter if you like. My Twitter handle is at the bottom of the screen if you'd like to keep in touch. Cool. Let's chat a bit about what Kubernetes is. And this is one of my favorite tweets. One time I tried to explain Kubernetes to someone, then we both didn't understand it. So I'm going to do my best to explain Kubernetes. Many have described Kubernetes as a container orchestration system, which is a good place to start, especially with mentally digesting what Kubernetes can do. But I kind of like to take us to visualizing containers and containers running. And imagine you have a handful of containers running on a server, let's say 5 containers. It's not that difficult to run 5 containers on a server. But let's increase that a bit. Let's run hundreds of containers. But that's not going to fit on a single server unless it's a huge server. And so now you might want to spread it across other servers. And maybe these hundreds of containers also exist in duplicates in different environments, dev, pre-prod, prod. Now it's getting a bit difficult to manage these containers. And now we kind of need something to orchestrate all of that. And that's kind of what Kubernetes solves. It solves those pain points of managing containers that you're starting to scale. And it doesn't solve this out of the box. You have to tell Kubernetes how to manage and how to orchestrate these containers, but there's a lot of functionality that does come out of the box that you can leverage. Then let's chat a bit about containerization. I like to think of it as this virtualization inception, like an operating system in an operating system. Containers are a good way to bundle your application. It's an effective way to package your software, and it solves that but it works on my machine issue. We now have environments that are duplicate. We can duplicate what we want to see in production on our own local machine. And it's a good place to start with cloud native practices. An interesting concept to think about is with this whole DevOps mindset, there's this phrase of snowflake servers. We have unique servers created for unique environments. And so and that's like, so every time you deploy your software, you might do a couple custom steps in it that you might manually have to do, or it's not necessarily automated yet. And then this kind of gives you the snowflake server that you're scared of going down. And I actually had an interesting situation before where I found people working with snowflake containers where they were too scared of their containers going down because there was too much dependent on these containers. So this is kind of a shift with Kubernetes where your containers should be able to go down and your system should be able to recover. You also, with all of these containers, you want centralized logs. And you might want to create like a dashboard where you can see all your logs, and you can already do that really well with existing solutions like Prometheus and Kibana. But those solutions plug really well into Kubernetes out of the box. Like if you use Helm, for example, you can install them pretty much on day one. And what you're hoping for is building a system that reacts, like it's a reactive system. It's a system that reacts when your containers stop running, your containers start to run out of resources. Well, sorry, your service, your environments start to run out of resources. And when your software itself starts to run, throw errors, and you can start to react to that and the visibility of all of that. So let's chat a little bit about some recurring architectural needs that we might have. For example, fault tolerance. Software and hardware will stop working, especially in the cloud. And so you want to build a system that will recover. And you kind of want to think, how does your company currently recover from faults? Do you have a team, a dedicated team that has to find these faults? Who finds these faults? Do your users have to tell you about problems? Or do you have systems that react to your problems? And just do you have a system that is kind of ahead of the curve in terms of finding faults, going around resource faults, software faults, hardware faults? I'm just going to leave those open-ended questions there. And then managing load. So how do you manage the load in your system? Do you vertically or horizontally scale? How do you need to add more RAM if your RAM is starting to run low, or CPU? Do you spin up bigger machines and then reinstall software on those bigger machines? And then the same thing in terms of load, in terms of like, do you have to manually go and increase your systems and increase what they need in order to run effectively? Or is this automated and scaled? What about your network traffic? What if your software starts to get bombarded with network? Maybe it's Black Friday. How does it react? Again, open-ended. Let's ponder a bit about those. Let's chat a bit about cloud, because Kubernetes sits on this layer. Let's chat about this layer a bit. So cloud gives you, it gives you a lot of APIs to work with. It's the three things that I always focus on is the elasticity, the on-demand approach, and the speed of cloud. Cloud is very much like a request-driven concept, and that's my own wording. So forgive me if I summarize it too simplistically, but it really is about all these requests that you want. You just want things and you request it. And then cloud just gives you what you've requested. And when I say elasticity, it also adapts to change. The change you tell it to, or the change, if it's a managed service, the change that it's promised to provide you with. It adapts to resource requirements. It can adapt to team size. So you just need more resources, just go and add more resources for your teams as they're scaling. And the on-demand side, request something at any time, day or night. It's whenever you want, 24/7. And you can automate these requests even and take yourself out of the picture. Put it as part of your continuous delivery pipeline. Put it part of your CI/CD. And staying up to date with latest versions. You can either use latest or you can use stable. You can use a past version if something's changed. It's that immutability of going to a specific version, expecting it to work in that specific way. And just this whole thought process speeds up delivery and software delivery and helps with stable change. All right, I threw this in here. If you're interested in going cloud native or learning about cloud native, Katacoda is a great resource. It spins up the environments for you and then just takes you through the commands that you can run. So I do recommend it. And it's not only for engineers. It's really great. I do believe it's intuitive enough that anyone who is curious can go and take a look. Okay, but why Kubernetes? Let's talk a bit more about this, the initial point of this talk. Why Kubernetes? So what is still missing from cloud? I mean, I spoke about how great cloud is, and then what can you still get from a system like Kubernetes? And Kubernetes still utilizes cloud. So it's not like it's separate from the cloud. It just sits on top of cloud and like gives you the best of both worlds, the best parts of cloud that you want, especially that request approach, like request what you need as you need it. And then containers everywhere. And so Kubernetes really solves when you're working with containers and you're starting to think to scale. And one of the other benefits of Kubernetes is how it links up servers. So you could have a single server. Sorry, not with Kubernetes. You'd want to have at least 3 servers, but just hypothetically, you might have a single server with Docker containers. And then as your load starts to scale, you start to add more servers. And then Kubernetes basically links up all your servers that you need like into one super server. Like they're all part of one server. And that's like the nice networking layer that it has. And that also gives you that infinite scalability. I mean, I'm sure there's a finiteness to it, but hypothetically, infinite scalability. And as you need more, you just start adding more servers, and those are called nodes. And I'd like to also introduce you, if you haven't heard of this concept yet, the platform team concept. And so Kubernetes works really well when it has a dedicated platform team looking after it. And it's a shift from the concept of the operations team because it uses principles like SRE. And the idea is that as your company is scaling and as your teams are growing, do you have to keep hiring more people onto your ops team to cope with the scale of your company? And the idea is that instead of having skills that now need to be duplicated by hiring more people, build a system, and the system will cater for the load. Also less likely to have to do redundant tasks and just more innovative and exciting. But I'm not saying don't hire operations people. Definitely keep hiring operations people. The skills are still very valuable. We're just restructuring the skills into a platform team. And this team's focus is then to create a platform that the rest of the company then requests from. Requests services, requests Kubernetes resources, namespaces, but it helps the developers focus on what they need to do. And so just a quick quote from the Cloud Native Transformation book. The founders of our company wrote it, so I am a little bit biased here. But it is also really great. They take all of these cloud native concepts and they've put it into a book, and there's years and years of experience right there. And they've said, use your platform to build your platform. And what's really cool is that approach that while you're building your platform, it'll be solving and catering for itself. And so it becomes if it can solve its own needs, then it starts to be able to solve the company's needs. And to quote, there's a longer quote here that I'm going to read out for you. Create a team to be in charge of architecting, building, and running a single, consistent, and stable cloud-native platform for use by the entire organization so that developers can focus on building applications instead of configuring infrastructure. And I think why that stands out so much to me is because of the DevOps approach. Remember when I first got introduced to DevOps, suddenly I went from like full stack engineer to like, now I'm going to do infrastructure as well. And I felt so stretched out in terms of mental capacity. And I just think it's still definitely like the DevOps thing, go through the pillars. And I mean, we'll break down the pillars. You can still set up your own infrastructure. It's just it's specific to your project and not specific to the entire organization. So it's that focus that helps you kind of solve the right needs that the company needs. And another cool thing that you could do is rotate engineers. So sometimes developers can be in the platform team and learn about the platform and focus on the platform. So it's not about someone not getting to do that work. It's just more about making sure people can focus when they're doing all these layers of work. Cool. So let's bring up those architectural needs again, the fault tolerance and the managing load that I mentioned earlier. So Kubernetes is really good at solving these. Kubernetes is very good at things going wrong. It is a really great reactive system. And it's good at, it's elastic. It has those properties of cloud. It can scale. So how does Kubernetes actually work? So there's a Kubernetes API. That's a bit like a RESTful API. You can use the get, put, post, delete requests. And it is an endpoint that you can do against. But ultimately, what this helps with is it leverages this development language that hopefully you've already become familiar with, or you can at least go and look up. And there's a lot of documentation on RESTful APIs. So it's leveraging that knowledge that is out there. And then Kubernetes has the state management. And you tell Kubernetes, you give it a state, like you'll write YAML files, and you'll apply the state and tell Kubernetes about the state. And the Kubernetes observes what is the state you've given it versus what's actually running on Kubernetes. And if it observes any differences between the two, then it rectifies it. And it starts, so if something stops working, and you've told Kubernetes something needs to be running, Kubernetes will go and spin it up as soon as it stops working. Then you can extend Kubernetes. And this is also a great foresight of the Kubernetes project, is that they have kept in mind that Kubernetes itself might not solve all your needs, and you might want to extend the behavior of Kubernetes. And so they've got custom resource definitions. And you can use their operator pattern. And basically, there's a ton of controllers that do a lot of monitoring of things going on in Kubernetes. And you can extend that behavior with your own resources that you've defined. And I've just used those two books, not affiliated to those in any way. I don't know who's wrote them, but they are great books. They're a bit outdated now because the operator SDKs have changed, obviously, because it is cloud. But yeah, they're worth looking at if you're interested in looking at how to extend Kubernetes. Okay, then proof of concepts. This is a really great thing to keep doing with cloud. Take your ideas, and instead of spending a long amount of time and a lot of resources on your ideas, spend like 2 weeks. Try give yourself that challenge and your team that challenge. Take the single most valuable part that you're trying to prove will add value and create a POC. Now this is it's not meant to go to production. It's just kind of to learn and to see if it can add value. And then you just phase it, and then you keep making it a bit better and a bit better and a bit better. I work with a client that goes through 4 phases. So they start at POC, and then they go through each phase until they get closer to production readiness. And this is a huge client. They have thousands of engineers. And they're basically, so this is a corporate that has taken startup concepts like POC and so on, and they've integrated it into how they're applying their projects. So it is totally possible for a huge enterprise to use startup-like strategies to test out ideas internally. Cool. Quick checkpoint with everyone. I hope everyone's doing good. Hope everyone's excited. I'm really excited about Kubernetes. I love how it standardizes everything. I like that it caters for so many people in the industry. And it lets people either work with Kubernetes itself or just consume Kubernetes for what they need. And I hope I've helped plant a seed for the magnitude of what Kubernetes can do. And the alternative to Kubernetes, I mean, not other orchestration managers, I just mean container orchestration tools. I mean, if you were to go just straight to the cloud, you would then have to manage all these moving parts yourself. And that's kind of really a strength of Kubernetes, is how it manages all these moving parts across a scaling infrastructure that keeps needing to grow and change and adapt and build features. Now I'm going to shift a bit. So I spoke about the first half is kind of more just a discussion. Now I'd like to actually chat to you a bit if you're interested in learning Kubernetes. And I've said that Kubernetes for engineers, it's for anyone. I don't mean to exclude anyone from this next section. I hope you're still interested, and I hope it still is interesting to learn about how you would interact with Kubernetes. Cool, so let's embark on our Kubernetes adventure. Where should we start? You can run Kubernetes on your local machine. You'd have to just install some CLI tools. like Minikube, for example, and then you can just type Minikube start, and you'll have a local running cluster. And I'm going to demo Minikube later. You can create a kind cluster, create cluster, and then the name of the cluster. Then you have a kind cluster to interact with. What's interesting with kind, it stands for Kubernetes and Docker, which is a bit of like a mind shift. So you have a container orchestration system that's running in containers, which is pretty fascinating. And then Kubernetes on the cloud, and obviously GCP is what I'm going to focus on. And you can install the gcloud CLI tool locally, and you can use the CLI, the gcloud CLI, to spin up Kubernetes containers clusters from your computer. You just have to authenticate your gcloud CLI. And you can also go straight to the console. This is a quick screenshot. You have to enable Kubernetes Engine, and then once you've done that, you can go through and click Create. And I was very shocked by how smooth creating Kubernetes clusters on Google Cloud Platform is. It makes sense because they created Kubernetes. But I really hope that if you choose to try it out on a cloud provider and you're new to the whole flow, give Google Cloud Platform a try. It's really intuitive. Okay, so once we have a cluster, how do we interact with this cluster? Well, there's another CLI tool called kubectl, pronounced differently by different people. I enjoy calling it kubectl myself. It just flows for me. And kubectl helps you interact with that Kubernetes API that we spoke about. And there's a ton of little commands you can use. For example, kubectl get, kubectl create, kubectl delete. There's also a help screen, and it's also really great how much effort they've put into that help menu thing, help feedback. Because you can just keep going. You can go kubectl get help, and then it shows you some examples on how to use kubectl get and kubectl delete help, and so on. All of those, you can just keep going help, which I do a lot of. Okay, so now, once we have kubectl, how do we actually connect with our clusters? Because something has to tell kubectl that what cluster to connect to. And that's your kubeconfig. So your kubeconfig file ultimately has the YAML that will tell kubectl what cluster to access, and will have some certs and keys and stuff that will give it the permission. It's a huge file. You generally don't have to create it yourself. You can, if you choose to. It's a fun deep dive to learn how to create your own file. But you can also, the tools you use, like Minikube, for example, or gcloud, when you create a cluster, they automatically create your gcloud. Your kubeconfig. And then you can either export a kubeconfig environment variable, or you can pass kubectl that flag -- kubeconfig. And then you can then tell, you have to like specify, okay, now that there's a kubeconfig available, what actual config do I want to select to use? Because you can have a kubeconfig that connects to multiple clusters, but you can only really connect to one cluster at a time. So you've got details to connect to multiple clusters in your kubeconfig. So there is this kubectl config command, but it's pretty bloated and big. So, I mean, there's definitely easier ways to switch between clusters. So you can create an alias, so that kubectl config command, you can check into an alias, and then you just type an alias command rather than the huge command. Or there's a CLI tool, another CLI tool, kubectx. There's quite a few that solve this problem. I just happen to find kubectx and enjoy using it. And then you type kubectx, and then it brings up a little menu for you to select the cluster you want to connect to. And that's really great for me, because that's like less mental effort for me than having to remember like aliases. It's just me, my personal preference. Cool. Let's recap. Cool. So in this last section, we spoke about creating a cluster, and then we spoke about connecting to a cluster with a kubeconfig. Then we interact with a cluster with a kubectl CLI. Cool. And yeah, and then it's from there, you just start adding to Kubernetes, and you start interacting with Kubernetes, with your fancy configurations that you want to add to it. And so what are some of the Kubernetes resources that you could look at? So the ones I recommend starting with is the pods, the deployments, the services, and the namespaces. Pods, Kelsey Hightower had this really great explanation that kind of, like it was this light bulb moment for me when I heard him say this. But think of pods as your servers. So where you would have normally had containers running on a server, now you have containers running in a pod. And it's typical best practice to have one container per pod. You could have multiple containers. There are use cases for multiple containers, but it's not generally best practice. Then the deployment is like a safety net for your pod. So if anything goes wrong with your pod, your deployment there's a couple mechanisms in place. There's the replica sets and some controllers. But ultimately, your deployment is what tells all of that to monitor the pod and to make sure it's still running. Then got services, and those allow you to interact with your pod like with a service name. It kind of so that your pods will be assigned like a local internal IP, and that changes every time your pod goes down and goes up. So you need like something that's a bit more stable, something that doesn't change every time your system has to like restart a pod. And services give you that. They give you this consistent name you can work with. Then namespaces are, they help isolate the resources on Kubernetes for a user or for a team. Teams can share namespaces. You'd use RBAC rules to then restrict who can see what namespaces and what resources. But those are my chosen starting points for learning Kubernetes, and they're part of my demo. It's pods, deployments, services, and namespaces. Then just mentioning Katacoda again. If this has piqued your interest and you want to learn Kubernetes and you're not sure you want to spin up your own clusters yet, these are some free courses where they give you an environment to practice Kubernetes in. Cool. Just before I finish, and I'm almost done, is just some gotchas about Kubernetes. Kubernetes is really great, and I've said all the great things about it, but there's also some dark sides to Kubernetes. The learning curve. It is a lot to mentally take in. It's you know, I believe it's worth it. It's just keep taking in small bites, and there's a lot of great resources out there. There's Udemy courses that are really great, and other courses. I just happen to be thinking about Udemy at this moment, but there's a ton. There's also, I mean, Google has a ton of great courses as well that you could check out. And then the complexity. So at first, the complexity can feel overwhelming. But a lot of the problems that the complexity solves, I don't think we realize that actually, you know, we shouldn't have worked around it. It actually should have been solved because it makes our lives easier. And so I do feel it's worth pushing through the complexity and slowly understanding the layers of Kubernetes. And then Kubernetes also, it still follows that DevOps approach of shifting a lot left, and it still gives a lot of freedom to developers to still define things if they choose to. Obviously, different teams might choose different layers of responsibility in this life cycle, but the complexity slowly becomes like second nature. Oh, and Kubernetes skills are in high demand. That's why it's also worth pushing through the complexity. And then there's the day two problems. So setting up Kubernetes, creating your Kubernetes POC, that's all great, but that's your day one. Then as you're maintaining Kubernetes, then you start to go into day two realm. And that's where you start to have perhaps resources that you didn't realize were still up. So Kubernetes is really great at adding resources and spinning up resources. Not so great at, like, if you change resources on a YAML file and apply it, it's not so great at fixing that difference. There is a kubectl diff command where you can see the difference between what's on Kubernetes and your YAML. But as, like, for example, if you're building a platform team, as that starts to expand and different projects don't have the full YAML in them, they might have like more modular parts of the YAML, you might not always be able to see the full difference. I'm sure there's tricks to it, but there are tools that are solving this. And so there are GitOps tools, and GitOps itself is a really great approach for addressing some of these day two issues. And then, I mean, I do also recommend looking, if you are planning on going the Kubernetes route as a company, seriously consider the platform team approach, because that can help you a bit with this architectural debt that might start to accumulate with Kubernetes. Because Kubernetes is just like any other software that you need to maintain it, and you need to fix a technical debt. You don't set it up and then go, cool, we have now a solution. Unfortunately, it's a iterative platform, and you need to keep putting some TLC and love into it. I mean, not unfortunately, it's very cool. Okay, cool, demo time. I hope everyone's still there. Yeah, is it cool if I just jump into the demo? Okay, I'm going to do a bit of shifting of screens. Just bear with me.
I hope you like having me as company again. Yes, we would love to see that demo. Like, I'm just looking at the comments and they're like, it's so informative, and I look forward to seeing what you do with all that information. You'll make me blush, and then I'll give you another knock joke. Yeah. Okay, so definitely take it away with the demo, please.
Okay, great. Let's give it a go. Okay, now I'm going to share my entire screen. Okay, sorry, now there's Inception. Okay, so this is my repo. I throw a ton of things on. I actually created 3 demos for today, and I'm just going to demo 2. So if you want to go take a look at the third demo is a WordPress demo, WordPress on Kubernetes. Okay, so to start with, I've created like my own little GitOps solution. I was just curious if I could do it, and then this talk happened, and I was like, serendipity, or I think there's a better word for it. But okay, so if I quickly show you, here's my GitOps file, and you can take a look at it on the repo. It's just going to do a lot of the spinning up on G-Cloud for me. So don't worry, we're not going to wait for it to spin up. I'm just going to run this quick, and then we're going to jump to a local cluster. So let me go back here. And how I've set this up, so one of the benefits of the GitOps approach is that your Git behavior triggers your automation. And so in this case, I've got release tags, that naming conventions of the release tags. I've got delete dash, deletes the cluster that I'm about to spin up, and I've got release dash, and on the release it creates it. So I'm quickly going to create a release tag, and this is going to spin up a GCP cluster for us. And then I'm going to get a bit more hands-on with the local cluster. Oh wait, sorry, I've zoomed in so much now. I'm not used to seeing the screen like this. There should be a create somewhere. Nope. Okay, just bear with me one moment as I cheat. Ah, there we go. Okay. So you can see I've been testing a few times. Create our cluster for the demo. Oh no. Okay. So now I'm just going to publish this release. I'll show you quick. GitHub Actions. It's going to go in and do a ton of things in the background for us, and it's going to. Well, I hope the demo curse doesn't hit and it doesn't work. But it's going to set up like a VPC, and then it's going to set up the cluster on the VPC, and all of the commands are there. You can have a look. Okay. While that's doing its thing, because that's going to take a while, I'm going to quickly demo an Nginx example. And the reason I chose this particular approach is I thought I would start with Docker Compose. So we'll start with just the Docker layers. And then from the Docker Compose, I'm going to spin the same kind of environment up in Kubernetes, and then I can actually show you the differences between how Docker Compose has been set up and how Kubernetes has been set up. Okay, so to start off with, I'm going to run Docker Compose up. Great, my containers have already been downloaded, so that helped with speed. And then, then I would just want to, so I'm going to do a little bit of screen shifting. I hope it doesn't become a bit confusing, but right behind the browser tab, I've got my Visual Studio Code tab, and I'm just going to shift a bit between those two. But it's the only screens I'll shift between, and I hope that works okay for everyone. So here we've got the Docker Compose, and I've created a tag, and so it's going to tag with this tag, and it's building. So with this build thing, it's going to build my Docker file that I've provided it with, and yeah, it's going to spin up. Well, it has already. If we go Docker PS, there we have this carry Nginx running. So it's running on port 8000. Oh no, not Firefox. I have so many tabs. Yeah, let's go back to Chrome. Okay. We're going to quickly open up localhost. Cool. And so this is our little example with Nginx. It's also a shout out to Women Techmakers and International Women's Day. So 2 birds with 1 stone. And now let's take a look at spinning this up locally on Minikube. So let me just clear this quick. Let me hide this. Okay, that's still running. Hopefully it's no errors. Oh, it's still running. It's good. Just let it go in the background. Okay, so let me check my steps. Where are we? So we've just created our Docker Compose, and I've added that to the README if you want to spin this up yourself. We've opened up the local host. And then I've pushed this image publicly to my Docker Hub account. So it's a publicly accessible image tagged with what I showed you. I think I can actually go take a look quick. And that's what's allowing my Kubernetes cluster to retrieve the image. So it's not my local image that it's retrieving. It's still retrieving an image from Docker Hub. It just happens to be my account that I created. Okay, let's check if we've got Minikube. I think I did check just now. Okay, cool. Minikube is running. Then let's just check my kubeconfig is set. Cool, that's set. And then we want to, so let me just quickly run a command. Let me actually interact with it. So for kube control, get nodes, and nodes are like the servers that I mentioned before. How many do we have? Okay, we just got 1. Minikube is a single node server, which is a good thing for local development. Cool. Now, I'm quickly going to show you if I go kube control, get namespaces. Remember I spoke about that. So these are the default namespaces you get usually on a Kubernetes cluster. They're like system namespaces, and then the one you're on is default. And this actually also shows what namespace I'm on. I've got some information there in the terminal. Let me just bring this up to the top again. Okay, and then I'm going to go kube control get, and we want to get pods and services just to see what's running. So right now, I left my example running. Okay, let me quickly delete that. Control. So now you get a bonus example of how to delete Kubernetes. Okay. Okay, so now if we get pods and services, now we only have a default service that's running on the cluster, but we don't have anything running right now. Now I'm going to go similar to how I just did a delete. I'm going to go kube control apply -f flag, and I'm going to pass it the Kubernetes folder where I've got all my configs. Oops, would help if I tell it what folder to go into. Okay, So now it's created my deployment and it's created my service. And you might say, hey, what about pods? And what about namespaces? So because I didn't specify a namespace, it's going to create the namespace on the namespace I'm in right now, so default, or if I was in another namespace, that namespace. And the pods are actually created by the deployment. So that's sneaky, does it for you. And then quickly going to show you the Kubernetes files. And so the deployment is a bit like, if we look at the Docker Compose, it's a bit like this information, the ports and the image information, and even the restart information. So yeah, we've got the image under, oh, sorry, that's very zoomed in, so it's not much space for my cursor. Okay, let me just minimize this actually quick. Okay, so here we've got our image that we specified, and the port that we would like to expose. And there's another little nice feature here, replicas. So if we were to, for example, change this to 3, so let's go control get pods. See how you have one pod running. Now I'm going a bit rogue here. It's a nice thing to show. Now we've got 3 pods running because and Kubernetes is smart enough to know that when you reference the service, and the service is like what links to the pods in terms of being able to use it in your links and your URLs when pods are referencing each other, Kubernetes is smart enough to know that any of these is what you're referencing. So it'll do like a little bit of internal round robin load balancing. It's a tongue twister. Okay. And so let me quickly show you the service. And if we look at the Docker Compose file again, and kind of like here, the service was Nginx. And if we wanted to reference Docker containers on a Docker environment, we would call this container Nginx because its service name is Nginx. And so with the service here, the name is, oh, so sorry for all that. I've never been this zoomed in before. Okay, so the name is Nginx-service, and it's exposed on port 80. So this is the interesting thing with Kubernetes is you have to expose the pod, and then you still have to expose the service as well. And then it's, because it's type cluster IP, it's still only internal. So it's not actually publicly accessible. It's like a local service. And you have to specify the port of the container and then the port of the service. So you can change the port to anything you want. But I don't need to change it for this example. I'll show you quick. What I'm going to do is I'm going to use a little sneaky trick. I don't feel like setting up load balancers and ingresses and any complicated like networking rules to expose this as a demo. I'm going to use port forward. And I'm just quickly going to run this command here. It's going to expose the port 80 on the service to port 8005. So that's still the Docker one. 8005. Sweet. So now we have, and you can see here, it's actually, we're hitting that. Okay, I thought it was going to like spit out more logs for us. That would be nice. Okay, but you're hitting this. You can see that it's all connected on Kubernetes. So let's quickly take a look at our example here. It looks like it finished running. I have a feeling it's just the UX hasn't updated yet. And so there, okay, yay, success. So I'm quickly going to, so now that I've canceled the port forward command, now this is no longer going to work anymore. So it's not publicly accessible. It makes it pretty secure to test locally. And I'm going to demo to you quickly. You can use the exact same command on a cloud-based cluster and still test locally. So what I want to start with is I want to quickly show you the clusters on GCP. So if we go gcloud, container clusters list. I should have showed you this before to prove to you that there wasn't a cluster. So this is our cluster we've created now. And it's pretty zoomed in, so it looks quite cluttered there. But I just want to show you that it is the same cluster that we've created. So here's the create cluster command. And so this is the command it ran. And it ran this GCP demo cluster. So create GCP demo cluster, and that's the one we've got now. So now what I'd like to do is switch contexts. So I'm currently still in the Minikube context. I'd like to switch to the cloud context. So I'm going to use that kubectx tool. Oh, I skipped this step. Okay. This is all good. This is just that I need to still pull down the newly created clusters kubeconfig details so that I can connect to it. And I am going to run this command. So this is a gcloud container clusters, get credentials, and I pass it the cluster name. Actually, that is not the right cluster name. So I'll fix that now. And then you have to pass it the region. If your GCP already use multiple regions, you kind of have to explicitly say which cluster in which region. And this is not the manual demo, this is just a DCP. Okay. Now I'm going to go kubectx. And there we go. Now we've got our two clusters that we can switch between, just like that, like just local cloud, local cloud, local cloud. Okay, and I'm going to go to the cloud. And let's go again to control get namespaces. There's going to be a bit of a delay. Okay, and there's an extra namespace here. There's a monitoring namespace. So one of the benefits of the GitOps approach is that you can commit those YAML files to a repo. And then if you use GitOps, you can automatically assign YAML changes to a cluster through the mechanisms of Git, like, for example, a release tag like I did. And what I did was I used Helm charts, but I used Helm templates. So I didn't just apply Helm charts directly. And this is an approach I learned from my colleagues, is to create a single source of truth, if you don't mind me using that phrase. But basically, I can see what has happened to my cluster because I have all of my YAML files here. But I also just want to point out how many YAML files I've just saved myself having to write myself. This is a lot of information. And so Helm is a bit like the node modules of Kubernetes. Not quite as elegant, but it's the best way. It's the best way to describe it. That you can get a lot out of Helm that's already been configured for you, and then you can also add like variables and stuff. But I haven't done that. I've just stuck to a very standard Prometheus installation, and all my steps that I've taken to create this cluster, I've put in the README if anybody feels like kind of playing around with some of these ideas, including how I set up the Helm templates repo and the command I ran to get the templates, if you want to, because you can run that yourself locally, and then you just have to install the Helm CLI, and then you can install the Prometheus charts yourself. So I just quickly want to, so right now, I believe I'm on the default namespace. Even though it says none, I'm just going to, it's another great tool, KNS, helps you just quickly change to a namespace. So now I'm officially now on the default, so I don't have to guess. Okay, and now I would like to, so this is from my local machine. I'm still in, let me clear this. I'm still in the Nginx repo, and I want to run that same command, control apply -f Kubernetes. And You don't want to do this really with a platform. You don't want to apply local changes, but this is just for the demo. So do as I say, not as I do. But you can do this for testing, and this is just how great and flexible Kubernetes can become for testing and innovation and ideas and test and POCs. Okay, so now if I go keep control, get pods and service. Cool. So now I've still got the 3 scaled Nginx, and so even that, it's because I've stored it in my files. It's consistent there. And if I check, there's a service here, and so that same command that I ran here can run, and now I can literally test. So I'm gonna just change the port to kind of show. I can test the cloud, the container running in the cloud on my local machine. Hey, it worked. So happy this demo is working. So there's one little part that I still need to demo, and I might have just jinxed it. And this is the Prometheus part. So the reason I want to demo Prometheus is because you can also get Prometheus out the box to do quite a bit of observation already for your clusters. You don't want to set up a cluster that you don't have visibility of what's happening on the cluster. And so Prometheus is a really great way to pull in visibility of what's going on where, like, especially when these clusters start getting really big and spread out. It's nice to kind of keep an eye on what's going on. So let's just see what services are here. I don't think any of those are going to help me. So I think what I want to go onto, and I'm just going to use KNS again. I want to go to the monitoring namespace. And so now if I go service, now we'll see all these services now isolated to a different namespace. What I want to take a look at is the Grafana, and this came with the Helm charts, pretty fancy. Remember that kube control port forward command we just ran? This one. I'm going to use the same port forward here. And it looks like it's also running on port 80. And I'm just going to run it on 8001. No! Okay, so the reason it's failing is because I didn't say that we're port forwarding the service. So port forward is actually by default for pods. So you can actually test pods directly without a service. But then the pods, their kind of name changes every time. If we have a look here, see this long little suffix, I think that's what you call it. That changes every time your pods go down and up. And so then you'd have to update this command every time. And so I like to port forward on the service so that while I'm testing, I don't have to keep changing that value. Okay, let's take a look quick. And this wasn't working yesterday, so I hope it would now. Oh. Okay, I am using the wrong port entirely. It's not 3000. Okay, so now we need to log in. And I've got some instructions on how you can retrieve the login details, but it's always the same. So I'm just going to copy and paste those. And obviously you can change it. You can also plug this in with G-Cloud accounts. Sorry, not G-Cloud accounts, Google accounts. And so if your company is using Google accounts already, it's actually really nice to plug Google accounts authentication into this ecosystem. There's a ton of blogs out there and tutorials on how to do that, and Udemy courses actually as well. I'm not an affiliate of Udemy, just so you know. Okay, so I'm doing this manually quick. I didn't have time to automate this. So, and remember I spoke about service names. So I now just have to grab the Prometheus service name, and the Grafana pod will be able to communicate. And it's that service name, and it's the port 9090 that it's got there. So that's a port that's been exposed. Okay, I hope this works. Okay, green is good, green is good. Okay. Now, I'm just going to take a look at namespaces and pods. Like, I don't really know Grafana that well. I don't know Prometheus that well. But it's kind of cool that, like, even if you don't really know them inside out, you can still interact with them and get a lot of benefit from setting them up. And so, yay, we have activity. And let's jump around. So here we've got the default namespace. There we see our Nginx containers. There's a Prometheus operator. I'm not sure why it's on the default namespace. Then our monitoring namespace. Here we've got all the things that the Helm charts have installed for us. Yeah, and then there's just fancy squiggles and stuff. Yeah, so that's kind of right out of the box for you. And then you can customize it and make it do even more fancy things. So like right now, for example, it looks like I've got quite small nodes running, and they're already a third. And so I just created a 2-node cluster for this. Let's quickly just, I'm going to shut this down quick. And I'm just going to show you control get nodes. Don't worry about the errors. So I created 2 nodes, but that was because my command said 2 nodes. Like I mentioned, it's usually a good practice to go 3 nodes and up, because I think the idea is that your control plane needs like a buffer. If one node fails, it needs to kind of like redirect certain instructions. And if you only have 2 nodes and one goes down, it kind of like breaks. It doesn't know how to recover from that. So yeah, Kubernetes is great with scale. They might have actually fixed this issue. I think I remember reading somewhere that you can now have 1-node clusters. I mean, Minikube runs on 1 node, so it can't be that bad. And then before I finish my demo, sorry that I switched to this so quickly while I was still talking, but this is a great teacher. Mamshed Manambeth, I hope I've pronounced that correctly. His courses are amazing. I watched his courses and I was able to get my CKA certification. So I really do recommend his courses. Depending on where you are in your journey with Kubernetes, take a look at them. They're definitely worth it. Cool, and that's my demo. If you have any questions, let me know. Where is our host? We want you back. I really should have found jokes. Fire!
Oh my goodness.
Can't help it.
Oh I was having like a technical block. I was just clicking. Nothing was happening. Oh my goodness. Sorry about that. But I am here, and as you were talking, I was literally taking notes for days. Like, I am not even kidding you. It was just like notes upon notes, so much learning. Yes, thank you so much for your time, Carrie. Like, I really appreciate it, and the learning. I hope you guys took away as much as I did. And I'm definitely going to be following that guide to get my certification too. I was like, shoot.
Yeah.
Okay.
He's amazing.
Yeah.
Do it.
No, I'm looking forward to it. I'll just be switching over to the slides just to finish and wrap things off. But thank you again for taking the time. Thank you, Carrie. Thank you to the audience. And
thank you, everyone. Thank you for coming.
Okay. Okay, so you are back with me again, and I'll be sharing my screen real quick. So just to finish off the slides, to finish off the afternoon, thank you for spending time with me. I hope you guys thoroughly enjoyed the demo as much as I did. Love that you incorporated Women Techmaker and International Women's Day, and I hope to see you guys at the event coming up soon. So stay glued to Twitter, stay glued to YouTube, Instagram, and so forth. Yes, but first, lastly, well, before we end off, I'd love to give a massive shout out to GDG Polokwane, GDG Johannesburg, especially Pamela Hill. Like, she has been an amazing support structure. Nova, JetBrains, for all the wonderful goodies that we'll be receiving and giving to the speakers. So if you guys would love to give a talk in the near future, please reach out to GDG Polokwane, and then hopefully you'll also be giving a talk, right? And as this event is ending, you'll get a survey. Please check your emails. Please reply to the survey. So the ones with who's really quick at replying will be getting a JetBrains voucher. And we'll be going through the surveys, and there'll be a random selection with regards to the rest as to who gets the other JetBrains voucher. And then I just want to say thank you everyone for spending your Thursday afternoon with me, learning about Kubernetes, and I hope you continue learning. I'll be posting what I've been learning, and I hope to see what you guys come up with, build, and learn. And that would be a wrap for tonight. Thank you guys for joining. Bye.